the first commodity and Q the price for the second. Okay, then we can just say that X represents the unit of the first commodity, and Y the units of the second commodity that the person bought. Okay, we will have Y, which represent the quantity, the units of the second commodity. So assuming that negative purchases of either commodity are impossible, so we couldn't buy negative quantity, we can just assume that both X and Y should be positive or equal to 0 at least. So we can just say that X and Y should be greater or equal than 0. Okay? And we can now define the sets, the budget sets. So we can just say, okay, what is the set that describe our budget? And we can write the set by trying to understand how we can make the equation. Okay, so the set will be defined by the pair xy, which can satisfy which this equality actually. It should be that the price for the first commodity multiplied by the units for the first plus the price for the second multiplying by the units, which will be by, that's total, that sum should be less or equal than them. So we couldn't buy more than the total amount of money that we have, with the two additional requirement that both variables X and Y should be positive. Now we want to draw, I haven't said that, but for sure all the three quantity M, P, Q in this case should be positive. Okay, we are talking about money, about price, so we couldn't consider, let's put it right, but obviously that M, P, and Q are quantity, represent money in quantity, so that should be positive. Okay, so at this stage, I want to make a plot, let's say a sketch of the budget set in the XY plane. Okay, so I want to study with you what is the reason that describe this budget set. So I move on by choosing actually some parameters for some value. Generical value for M, P, and Q, we can just put M equal to 10, for example, P equal to 1, so the price of the first commodity is 1, the price of the second one is 2, and I can just say that from that this equality, it turns that X plus 2Y should not be greater than 10. Which is our total money. And both X and Y should be positive. So it will turn into such kind of system of this equality to be solved. Okay? So now we just need to underline, to find the region on the plane that describe these three disequality, and in particular at the end we want the region that overlap the three. Okay, so let's try to understand on the plane how we can derive this region. Maybe for the second and the third, the equality are quite easy to be understand. The first one is actually a straight line, so we can just put it in the explicit form by isolating y, and then draw the line. So I will start with doing the research of some points which belong to the first disequality. So let's put it in the explicit form, which turns into y equal to -1 on 2 plus 10 divided by 2, which is 5. So this will be our straight line, the first equation, let's say, and we can make, as we have done yesterday, some points to draw the line. Oh, sorry, I forgot the x here. So now I can choose 0 and obtain 5. I can just use 0 for the y and obtain 10. And I can choose 2 and obtain 5 minus 1, so 4. I can also take negative points, maybe -2, and it turn on 6, the y. So let's prepare the xy plane. Okay. Here x and here y. Let me draw the line, the first line, the first straight line, and then understand how to choose the region. Okay. So the points are 0, 5, 1, 2, 3, 4, 5. Okay, I can also use 2 square to draw it. Then I have 0, 10, so it's quite. So it's here actually the point. So maybe just. No, let's use only 1 square. Okay. And in any case, I would be here. So now let me cancel for a moment the. I'm gonna put more down this line so I can draw better the points. So it's a 0, 5. So here, then I have 10. No. Sorry. I have 0, 5. So it's here. And then I have 10, 0. So 2, 4, 6, 8, 10. It's here. Then I have 2, 4. Here. I have also 2 minus 2, which is 6 here. I can just draw the line, which is actually there, more or less. No, that's awful. Oh, okay, better. Okay, so that is our line. Okay, the first one. So let's now highlight the region. Okay, how can we do that? We can just try to understand what is, since when we draw a line, the plane will be divided into 2 regions. We can see that we have a part which is up the line and one which is below. So how we can choose the region that is described by the disequality? So let's start with actually the 2 easier, the x greater or equal than 0 and y greater or equal than 0. We can just see here that if we consider the plane that has x greater than 0, we are focusing on the right side of the plane. So let's say, okay, we are x greater than or equal than 0. So it's will be, I'm gonna use vertical line. So it will be all this part, because the x are positive here. If we do the same for the y will be positive on the plane up the x-axis. So I can draw this time horizontal line and say that this part of the plane is the one which has positive y. Okay, and then it will remain the last. Oh, sorry, I haven't colored the axis, but actually I should, because they're equal. Okay, so I can also include the the y-axis and the x-axis, right? So now I want to do the same for this straight line for the first one. On the, let's say, on the right or on the left side of the line. I can just make these things. I can fix a point. I can choose a point which is below or up the line and see if it's satisfying the equation. So, for example, let's take 1, 1, which is a point that is here. Let me let it. So 1, 1 is here. So it's behind. It's below, sorry, the straight line. So if I choose 1, 1, I choose the point 1, 1, and I substitute the coordinates into the first inequality, I will obtain 1 plus 2 less or equal than 10. And this is true, because 3 is less than 10. That doesn't mean that all the points which are below the straight line satisfying the disequality means this region. Okay, and now I have almost finished my problem because I can see there, which is the region that overlapped the 3 disequality, and it is exactly that triangle. In this part, we have the 3 lines overlapped. This is our set budget. Okay, the request of the problem. This is our B. That the so-called B here is exactly the area that we have found now by looking to the region with the 3 overlapped lines. Okay? Any questions? I hope that this can be quite understandable from everyone. But it's nice, a nice example on how it works, the use of the lines, of the straight lines, to understand some also, to interpret also some economics problem. Okay, if everything is clear, I move on. I want to going on by talking about the parable. Let's change topics, and we will have okay. Okay. So, first of all, we will only consider parabolas with the vertical axis, because we should highlight that parabolas with horizontal axis are not functions. So let's see first of all why it happens this. So let's take an example of a parable with the horizontal axis, say this one, for example, it is not a function because we have defined a function as a relationship that has only one y in correspondence to the x. Instead, if we look to such a graph, we can see that if we took one x here, let's call it x1, in correspondence to the x1, we will find two different value for the y. So this is not a function for the definition that we have done. So we can just say and write that parable with horizontal axes are not function. And I hope that this can be clear for everyone. So we will focus on the parable which has the vertical axis. So an example, I'm just drawing it now, can be this one. And it can be quite understandable that if I'm choosing an x here, I will only find a point. For example, here, yeah, there will be only one y in correspondence of that. Okay, so we will just consider the parables which has vertical axis. Okay. Okay, but moving on, we can just go into the general equation of a parable with vertical axis. So we can just write here that the general equation is y equal to, sorry, I'm gonna use, let's write here, where a, b, and c are known real constants. Sorry, I'm gonna write also the equation, but I'm gonna do it without the keyboard. So we can just say that the general equation is y equal to a x power 2 plus bx plus c. Okay. And it represents actually a quadratic equation that we have seen also yesterday. We can just quickly scan some special cases which are related to the fact that one of the coefficients can be equal to 0. So let's start with that. So first we can have a and b both equal to 0, but then it's quite easy to see that it will remain y equal to c that are horizontal line. Okay, we have already seen. That are horizontal line. Okay. The second case is if we have a equal to 0, but then again it will be not anymore be a parable because it disappear the power of 2 it will remain bx plus c, and this is the general equation of the line. This is the general equation of the line with m, the slope equal to b, and the intersect equal to c. Okay? So it's not both cases here, we have two lines. Okay, in order to be a parable, the power of 2 should be preserved, couldn't be delayed. So we can see the third case, still a simplification of the general parable, but still a parable in this case. If we have b equal to 0, so it will turn into y equal to a x power 2 plus c. And this can be defined as a general equation sorry. Okay, general equation of a parable which is symmetric with the vertical axis and the vertex of the parable has coordinates at the point, we will see later why, at the point 0, c. Okay, because if I'm going to use x equal to 0, it will turn into y equal to c. Okay, so the coordination of the vertex will be 0, c. And so just for drawing an example, it will be like that. And this will be your vertex, where actually this will be as value c. Okay? This case can be reduced to a version even easier, in which not only b is 0, but also c is 0, so it will remain y equal to ax2, and this is even even easier because this is the general equation which has the vertex in the origin. Okay, so they will be always v coincident with the center of the graph. This is quite horrible. Okay. Or can be also this way. And now we will see which are the differences. Okay. Last case before going to the more general one is if c is equal to 0, then the parable will become y equal to ax power 2 plus bx, and these are the general equation of a parabola passing this time through the origin. So the origin will be no the vertex, but it will in any case cross the origin, and it is quite quite easy to understand this point, because if I put 0 to the x, y will become 0. Okay, so I can just make also here sketch. and can be something like that, for example, okay? And so C is the intercept at the origin. Okay, we can just see that C represents exact that point. Okay, for all the parables. An important thing that should be noted, so we can just wrote here a note for saying that for understand what is the concavity of the parable, and we know that if the coefficient of the power 2, so if A is positive, then the parable is convex. If A is negative, then the parable is concave. What does it mean from the point of view of the graph? If some of you does not remember this concept, and it is important also when we will make the study of the function or the derivative, that doesn't mean that we will have something like that in the first case or something like that in the concave case. Okay, the last things to be highlights for the parable is the formula for calculate the vertex. So we can just say that the vertex V can be obtained, the coordination can be obtained by doing the x with the formula minus b divided by 2a and minus b power 2 plus 4ac divided by 4a. And I want you to focus on the fact that the part of the y, the numerator, here is what we have called yesterday delta in the formula which resolve the second order equation, but change of signs. So it's minus delta can be represented by minus delta. Actually, for obtain the y of the vertex, when we have determined the x, we can also impose the belonging of the vertex to the parable. Means that we can just substitute the x coordinates of the vertex into the equation of the parable, and we will obtain the corresponding y. Okay? So if we want to summarize some steps that can allow you to draw a parable, we can just put down 4 steps. I would just say, and in doing so, I want also to highlight what does make differences in the parable. So let's make some, let's put on right the steps required for drawing a generical parable now. So let's suppose we want to draw a x power 2 plus bx plus c, so a complete equation for the parable. The first thing is that we can, first step, let's say, we look to the coefficient of the power 2 of x, and as we have seen before, if a is positive, then we should expect a convex y. Okay, so we should draw something like that. If a is negative, then y is concave. So you should have something like that. And if when when you're making the graph, you have a negative, and at a certain point you will draw something in the convex direction, that you have made some mistakes. Okay, so that is another verification. The second step is the intersection with the x-axis. What does it mean, the intersection with the x-axis? Means solve the system which between the x-axis, which has the equation y equal to 0, and your parabol, so y equal to ax power 2 plus bx plus c. But solving these systems means solving a quadratic equation. So ax power 2 plus x plus c equal to 0. And it is the second order or quadratic equation we have seen yesterday. So let's make a bracket here, let's say like that. I just want to highlight the fact that to solve that equation, we reminded yesterday the formula, which is x equal to minus b plus minus square of b power 2 minus 4ac divided by 2a. And I'm recall it because now I want to understand with you what does it mean, what actually change in the graphic of the parabol by varying the delta, so the terms under the square. We have already said this yesterday, but let's see the translation of that into the plot of a parabol. So we have said yesterday that if we have positive delta, so if b power 2 minus 4ac is positive, then we have two real and distinct solutions. Just right here, two real and distinct solution. And from the point of view of the graph of a parabol, that means that our graph always intersect the x-axis into 2 points, which are distinct. Okay? The second case we have seen yesterday is if that delta is equal to 0. That means that this time the solution will be too real, but now they will be coincident. Two real solutions, two real coincident solution. And what does it mean from the point of view of the graph is that actually the vertex will be on the x-axis. Because the vertex always belong to the axis, to the parabol, so we will draw something like that. Okay, there will be only one numbers that represent the two real coincident solution. Okay. The last case is if the delta is negative, and we have said yesterday that the equation will have no solution, no real solution. And what does it mean from the point of view of the graph? No real solutions. I'm going to put a small sketch here, but that's not a problem. Means that there is no intersection with the x-axis. Okay, So now we have made the analogy between the solution of an equation and the graphical representation of the parables. Since the solution of the previous equation represents the points of intersection of the parable with the x-axis, let's recap. In the first case, in case B, only one point, and in this case, it will be exactly the vertex. And in the last case, we do not have any intersection. Okay? Then, finishing the steps for drawing a parable, I can just say that the third step can be the intersection with the vertical axis, meaning solving the system x equal to 0, y ax power 2 plus bx plus c, which turns into y equal to c. So the point will have coordinates 0, c. This will represent the intersection with the y-axis. And the last step is finding the vertex. Find v, which is, as I said before, minus b divided by 2a and minus b power 2 plus 4ac divided by 4a. Okay, let's make any questions or problems or something not clear. Okay, seems no. Before making the eventually another break if it's needed, I want to make an example for drawing a parable, but a quick one without losing too much time. For example, let's take this the parable. Let's move on. Okay. Let's consider the equation y equal to minus 2x power 2 minus 4. So first step is checking the sign of a. So a is equal to minus 2, which is negative. So we would expect to have a concave graph. Okay. Second step is solving the intersection with the x-axis. So y equal to 0. It turns into minus 2x power 2 minus 4 equal to 0. We can just solve that equation by highlighting to the fact that it will turn into x power 2 equal to minus and possible. Okay? Because a power of 2 equal to a negative number doesn't make any sense. So there is no x that satisfies this equation. And this means that we have no intersection. This is the case in which our parable will not intersect the x-axis. Okay? We can now do the third step, which is the intersection with x equal to 0. And we can see that it turns into y equal to minus 4. And as we have said before, this will be also our vertex. Okay, this is exactly our vertex. And it is quite easy now to draw the parable. We can just put it here. There is no intersection, so I wouldn't expect anything on the positive part. It will be concave. I can put the vertex here. This will be our vertex. And now, if I want to draw it even better, I can also choose a couple of points, as we means I can substitute, for example, 1 to the x, and I will obtain -6. So I can also say that these are 2 points belonging to the parable, and I will draw something like that. Okay, any questions, doubts? I think that most of you should already know this concept, that maybe can be also a bit bored, but since we have passed already the summer, maybe some concept was forgotten somewhere in your mind, so it can be also useful to have a look on that. So tell me if you agree to make another 10 minutes of break, just to scratch the legs and maybe drink something.
Yes, that will be great. Thank you.
Okay, so let's make the 10 minutes of break. I will restart by doing last things about the parable, which are the resolution of the disequality with the use of the parable, because yesterday actually I have only used the sign scheme. I want now to make the parallel, at least in a couple of examples, with the resolution of the disequality. So I will spend 10 minutes on that, and then I will move on showing you the other elements that can be useful during the course. Okay. Okay. Let's rejoin in 10 minutes.